let's look at the complex plane and de Moivre's. He's French, so you got to say Moivre's theorem. So we have this imaginary unit, so hopefully you kind of sort of remember the imaginary system, maybe possibly, where I squared equals -1, kind of, sort of. Or if you remember when you took the square root of a negative number, it was I. You might remember it that way. If we have our complex number system with an imaginary unit in standard form, then this piece right here is the real number. This piece right here is the imaginary number. And so, for example, if we want to add or subtract these, you kind of just do them like you're used to variables, right? Even though I is not a variable, it is an imaginary number. Where my pencil? There it is. Is you just collect like terms. So my like terms here, notice I'm adding, so I'm not multiplying. And so I'm doing 3 minus 2, which would be 1. And then 5i plus 3i, which would be 8i. And that would be your final answer. So nothing really weird to it. The only thing here, just be careful that you distribute that negative sign. So minus 6i. And now you can collect your like terms. So 6 minus 3, 3. Hello. 4i minus 6i minus 2i. What happened to my tree? My tree. And that would be your final answer. So again, just doing the real part and then the imaginary part. All right, when you multiply, again, it's kind of what you're used to multiplying FOIL in this case. So 5 times 2, 10. 5 times 7i, 35i. Be sure you do sound effects when you do these. 6i and plus 21. I times I is I squared. So I collect like terms. So that would be 41i. And then remembering that I squared is -1. So this becomes 21 times -1. Or it becomes 41i minus 21. And now I can collect these like terms. So I end up with negative 11 plus 41i for my final answer. All right, so this is probably the only piece you have to remember is that whenever you see an I squared, to change it to -1. Okay, when we talk about conjugates, you're used to the word conjugate because that's where you have like a radical in the denominator and you multiply by the same radical. Usually you just change the sign. Well, typically that's what you're going to do here with complex conjugates. So for example, if I have and this line over it means it's the conjugate. If I want to take the conjugate of a plus bi, it's just a minus bi. So down here, 2 plus 3i becomes 2 minus 3i. Notice both of your, when you're looking at this, notice that the a, this sign doesn't change. So both of them didn't change. It's only this middle. So if I want the conjugate of -6 minus 2i, the -6 stays the same. And so the imaginary part, which you're going to see why, is the part that's actually going to change. So if I want to find the product ZZ, where Z equals 3 minus 4i, again, this being the conjugate piece. So this would be like a dish, would be 3 minus 4i, and then 3 plus 4i. So that's the conjugate piece. Well, again, I'm going to FOIL. So 3 times 3, 9, 3's for 12i. And hopefully you can see, maybe you even remember in your nice little algebra days, what happens here is that the middle term cancels out. Okay, so that goes away. And then once again here, I squared becomes -1. So this becomes 19 plus 16, 19, 9. I didn't put that there. 9 plus 16, which equals 25. So if you notice, if you square the first term and you square the second term and you add them together, you get the answer. So kind of a nice little trick to not have to always multiply these out. But again, this is the same as when you did in algebra, the a plus b times a minus b. So that shows this actual theorem. What I just mentioned right here is that when you multiply a complex number by its conjugate, all you have to do is square the first term and then square the second term, and then you add them together. All right, writing the reciprocal of a complex number in standard form. So I still got my pencil going here. So in other words, I'm going to multiply. Notice this is kind of like radicals, where we don't like a radical in the denominator. Same thing, we don't like a complex number in the denominator. So I would do these. Okay, so that would be my conjugate. And of course, if you do something to the bottom, you got to do it to the top, because basically all I'm doing is multiplying by 1, right? So the top, of course, is 3 minus 4i. We just did the bottom, okay, on that last example. So that ended up being 25. And then typically you write your answers in terms of the real. So I'm going to just separate the fraction and then the imaginary piece. And that would be your final answer. All right, so we'll be next lecture talking about how we can actually plot in the complex plane.